This video is to explain vertical stretch and shrink of parent functions. Today we have a parent function f of x equals absolute value of x. Let's first draw that parent function on the graph to the right. It starts with 0, 0. It contains the points 1, 1, negative 1, 1, 2, 2, negative 2, 2, and so on. So this is our parent function, our basic shape for this family of functions. On the purple function, we are now multiplying this by a factor of 4. What will that do to the function? It will start at 0, 0 still, because 0, the absolute value of 0 is 0, times 4 is still 0. So we still have the origin as our point for this particular function. However, if I was to do 1 absolute value of 1 is 1, and 1 times 4 is 4. So now I have the point 1, 2, 3, 4. Absolute value of negative 1 would be 1 times 4 would also give me 4. So now I have the point negative 1, 4. 2 times 4 would give me 8. And negative 2, once I take the absolute value as 2, times 4 would also give me 8. What happened to the function? Notice it got a lot steeper. It stretched vertically. It is like I took this origin point, held it down, took these blue and pulled it from the top. So when we are multiplying a number by a parent function, it is going to stretch the parent function vertically. Again, hold the bottom, the point is the same, but it will stretch it vertically. If it was going down here, it would pull it from the bottom. So it's holding it in this middle position and pulling from the top and bottom to make it stretch. Now let's look at the green function. F of x equals 1/2 times absolute value of x. Let's do the same process. If I start with 0, then I multiply that by 1/2, I still get 0. So I still have this point there, the origin. But if I take the absolute value of 1 and 1 times 1/2, I get 1/2. So now I have 1, 1/2. The same thing with the negative 1. I get 1/2. Let's look at 2. 2, absolute value of 2 is 2. And then times 1/2 is 1. So now I have 2, 1. Absolute value of negative 1 is 1 times 1/2 is negative 2. Absolute value of negative 2 is 2 times 1/2 is negative 1. And we could continue on that direction. So what happened with this graph? This graph got wider, but we want to think in the vertical direction. So vertically, up and down, it actually shrunk. It got smaller. It's like I pushed it down from the top. It's like I took the blue and pushed down to make it wider. So even though this looks bigger, further apart, this is actually called shrinking. This one that's skinnier is called stretching. And again, we're thinking in the vertical direction, the up and the down. So we're going to shrink or stretch. And so here's our rule for that. If the number that we have in the front, we're going to call that A. If this number A is greater than 1, it's going to stretch vertically because it's going to go up by a larger factor. If this number is between 0 and 1, it's going to shrink vertically because it will not quite go as far up. It's only going a half or a third or a fourth of the original function. That's how you determine how to stretch or shrink a function in the vertical direction.